Let's talk about a non-isometric transformation, which is called a dilation. But before we get started on anything new, let's take a quick second to refresh our memories about what we learned about isometric transformations in first semester. We learned how to do 3 different kinds of transformations in first semester. We learned how to translate, reflect, and rotate. A translation moves a figure up, down, left, or right. A reflection flips a figure over a line, and a rotation turns a figure a certain number of degrees around a certain point. All 3 of those transformations were what we call isometric, which means that they preserve side lengths and parallel lines and angle measures. But today we're going to be learning about something that doesn't do all that. It's a non-isometric transformation, which is called a dilation, and it makes things bigger or smaller. You might actually recognize the word dilation from the eye doctor. When you go to the eye doctor, sometimes you get your eyes dilated, which means they put special medical drops into your eyes to make your pupils much, much larger. That, in geometric terms, is called an enlargement. And that's the general idea of what we're going to be doing today. Remember that the original shape that you're given is called the pre-image, and then whenever you complete the transformation, that new figure is called the image. The pre-image is labeled with just normal letters, so like triangle ABC. But after you've completed your transformation, you put apostrophes on each letter to represent that it's the vertices of the image. And those apostrophes are pronounced prime. So that would be triangle A prime, B prime, C prime. And yes, you do have to put a prime on every single letter. So like I already alluded to, isometries is what we already know how to do. Those are the types of transformations that just move a shape around the coordinate plane, but don't actually change it. It only changes its location. Today we're going to learn about the non-rigid transformation of dilations, which is going to make our shapes bigger or smaller. If your shape gets bigger, so your image is larger than your pre-image was, then it's called an enlargement. And if your shape gets smaller, so your image is smaller than the pre-image was, then it's called a reduction. You can also determine whether it was an enlargement or a reduction based on the scale factor. Remember from earlier this unit, we learned that scale factor, for some reason, is called K. So if K is bigger than 1, then it got bigger. It was an enlargement. But if K is less than 1, specifically between 0 and 1, we don't want to go negative here. We're just talking about numbers that are like a fraction or a decimal that's less than 1, like a half or 0.2 or whatever. Those types of numbers make your pre-image a smaller image. So we would call it a reduction. In order to calculate K, the scale factor, you use this ratio. C is the center of dilation. It's a point that you'll be provided that tells you where to dilate from. And then P and P prime are points on your pre-image and your image. So you'll notice that the image is on top because it has the apostrophe, so that's CP prime, and the pre-image is on the bottom because that's just CP. So for your scale factor, it's always new length over old length, image length over pre-image length. So let's take a look at an example. I want you to tell me if this is a reduction or an enlargement and tell me what the scale factor is. Well, the first thing to do is orient yourself to which one is the pre-image and which one is the image. The pre-image is the one that has just normal letters, P, Q, R. And the image is the one that has apostrophes, P prime, Q prime, R prime. So we started with the green triangle, and then we dilated it to the yellow triangle. And you can visually see that it got smaller. So this must be a reduction. But a reduction of how much? What is my scale factor? Well, to calculate the scale factor K, you always put the new length over the old length. My new length is from P prime to C, so that would be 4. And my old length is from P to C, so that would be 6. You could say that your scale factor was 4/6, but really that's incorrect because you could reduce that fraction, so we would say that the scale factor is 2/3. And you'll notice that 2/3 is less than 1, so again that confirms that our dilation was a reduction. Let's look at another one. P, Q, R, that's my pre-image, that's the triangle I started with. And P prime, Q prime, R prime is my image. That's where I ended up after dilating PQR. So you can visually see that we got bigger, so I would call this an enlargement, but an enlargement of how much? What is my scale factor? K is equal to the new length, which is from C, the center of dilation, to P prime, so that's 7, over the old length, which is just from C to P, so that would be 3. Now 7/3 doesn't reduce, leave it as an improper fraction, that's totally fine. 7/3 is bigger than 1, so I will say that this is an enlargement. Our next example looks a little bit different than the first two, but it's the same general idea that you need to identify which triangle is the preimage and which one is the image, and then identify whether it was a reduction or an enlargement and calculate the scale factor. The green triangle is our preimage because that's just triangle PQR. And the yellow triangle is our image, because that's P prime, Q prime, R prime. So obviously we got smaller. That big old green triangle shrank to become the yellow triangle, so I would call this a reduction. But we have to calculate just how much of a reduction it was by calculating the scale factor. The scale factor is always equal to the new length, the prime length, if you will, which is 5, over the original length, the pre-image length, which is 15. And that reduces to 1/3. So the scale factor of this dilation was 1/3. 1/3 is less than 1, so this must be a reduction. Dilations work the same way even if it's a rectangle or a dodecagon or anything other than a triangle. So let's try one that's a rectangle. Same idea as before, identify which shape came first. That would be rectangle PQRS. And then the image would be P, Q prime, R prime, S prime. Sometimes you'll see this where the center of dilation is actually one of the points on the original figure. So you could call it P prime, but since it's already called P, we'll just keep it like that. So the green rectangle was enlarged to become the yellow rectangle. So let's calculate the scale factor. We'll need to do new length over old length, and we actually have 3 different numbers to pick from this time, so you have to make sure you're choosing corresponding lengths. I don't know the length that corresponds to R prime, S prime. That would be the length of RS. I don't know what that is. So instead I'm going to be using the 24 and the 9 because those are corresponding lengths, QR and Q prime, R prime. So make sure that you calculate your scale factor with new length of 24 over old length of 9. And those are both divisible by 3, so my scale factor is 8/3. And since 8/3 is bigger than 1, this is an enlargement. We can actually use this information to calculate the missing side length RS. Since I know one pair of corresponding side lengths, and I know one of the 2 corresponding side lengths on the other side, I can set up a proportion to solve for the missing side length RS. New length over old length is equal to new length over old length. Let's take a look. New length of 24 over old length of 9 is equal to new length of 12 over old length of, I don't know, so we'll just call it RS. Cross multiply and solve. So RS must be 4.5 units long. We can also perform and describe dilations in the coordinate plane. If the origin, which is the point 0, 0, is used as the center of dilation, it's actually super easy to perform a dilation. You just multiply each of the pre-image coordinates by the scale factor, and then graph each of those points. Let's take a look. Here we have triangle ABC, and we're supposed to dilate it using a scale factor of 2. The first thing you need in order to perform a dilation in the coordinate plane are the coordinates of each of your pre-image points. A is the point 14, B is the point 11, and C is the point 51. To figure out the coordinates of your image, just multiply each of these coordinates by your scale factor of 2. So 1 times 2 is 2, and 4 times 2 is 8. So those are the coordinates of A prime. 1 times 2 and 1 times 2, well that's 2 and 2, so 2, 2 is the coordinates of B prime, and 5 times 2 is 10, and 1 times 2 is 2. So those are the coordinates of C prime. Now I can graph each of those points on the plane, and connect them with a triangle, and ta-da, you performed your first dilation in the coordinate plane. You can verify that you did this correctly by counting a horizontal or a vertical length on the pre-image and on the image and verifying, in this case, that it's double. The length of AB was 3, the length of A prime B prime is 6, and 6 is double of 3, so yeah, looks like I did it correctly. Let's try another one. This time we're going to dilate using a scale factor of 1/3. The first information I need again are my coordinates. W is the point 39, X is the point 99, Y is the point 93, and Z is the point 00. To figure out the coordinates of my image, I'm going to multiply all of those numbers by a third. 3 times a third is 1, and 9 times a third is 3. And so on and so forth. And you'll notice when I get to z, 0 times a third is 0. So z actually doesn't go anywhere. The pre-image coordinates were 0, 0, and the image coordinates are 0, 0. If one of your points on the figure is the same thing as the center of dilation, then that point doesn't move. So w prime is here, x prime is here, y prime is there, and z prime is right where it started. So this little baby quadrilateral is the 1/3 dilation of the original pre-image. Again, you can verify you did it correctly by counting the lengths of a horizontal or a vertical segment. W prime x prime is 2, wx is 6, and yeah, 2 is 1/3 of 6, so it looks good to me. Let's try one that might be a little bit uglier, but we'll use the same process to get to our answer. We're going to dilate triangle FGH using a scale factor of 3/4. The first thing I'll do is write down each of my pre-image coordinates, and then I'm going to multiply all of those numbers by 3/4. 4 times 3/4 is 3, and 8 times 3/4 is 6. So those are the coordinates of f prime. 8 times 3/4 again is 6, but 10 times 3/4 is a decimal. And that happens sometimes with dilations. Don't freak out about it. It's going to be totally fine. You'll just have to kind of estimate where that point belongs when you graph it on the coordinate plane. And same thing with our last coordinates for h prime. 6 times 3/4 is 4.5, and 2 times 3/4 is 1.5. So when I graph these points, you'll notice that g prime is halfway in between 7 and 8, and h prime is halfway in between 4 and 5, and halfway in between 1 and 2, so it's like floating in the middle of a square. And that's totally fine. That's where it's supposed to be to make this 3/4 dilation. And that's the basics of what you need to know about dilations, as well as how to perform a dilation when you're using the origin as the center of dilation. In our next video, we'll discuss how to perform a dilation in the coordinate plane if you're using a point other than the origin as your center of dilation.